All right, so let's see this particular question now. So over here we are given an integer array, right? And what we need to do is we need to push all the zeros in this particular array to the right end of the array while maintaining the order of the non-zero elements, right? And we do this mention change in the array in place, right? So we don't have to use any auxiliary array, neither do we have to create any any new array just to return as the output of the function. In fact, there is not going to be any output of this particular function. You just have to make the reordering and the rearrangements to move all these zeros towards the end while maintaining the order of the non-zero elements in place in the input array itself, right? So that's what we need to do. So if you see this particular example, the input array is this 120435050, and after pushing all the zeros towards the right and maintaining the original order of the non-zero elements, this is what we are going to get, right? So this is the problem statement entirely. Now maybe you can just pause this video and try to write a solution on your own. And once you are done, you can just come back and check the solution here. Okay. So now, the intuition behind solving this particular problem is that what we can do is we can keep traversing this particular array. And whenever we encounter a zero, our objective is basically to push that particular zero forward till the point till there is no more non-zero elements ahead of that particular zero, right? And we need to do this one by one for all the zeros present over here in the input array, right? We just keep pushing them one by one uh, till the point till there is no further non-zero elements present ahead of them, right, in the array. At that point in time, when we have done this particular activity for all the zero elements in the input array, we can happily say that we have pushed all the zeros towards the right end of the array, and while maintaining the order of the uh, non-zero elements, right? So that's on a very high level what we need to do. And how we can do that is we can actually initialize two pointers. First is the first pointer, like I can just name it as F, and then a second pointer, I can just name it as S, right? F will be initialized to 0, S will be initialized to 1. So initially F pointer will be pointing to my first element, that is the element at the 0th index of the input array, and the second element pointer, that is S pointer, will be pointing to my second element of the input array, which is at the first index, right? Now what I need to do is, like at any point in time, I will keep checking if my, the element at the first pointer is 0 or a non-zero, right? So if my current element at the first pointer is actually a non-zero, then I have to do nothing, right? I don't have to bother about it. I can just move my first pointer and my second pointer to the next elements each. I can increment both the pointers by 1, right, and move to the next elements, right? But if my current element at the first pointer is a 0, right, in that case, now I have to check the element at the second pointer, right? And there can be two scenarios around this. One scenario could be that my element at the current second pointer is also a 0, and the second case could be that my element at the current second pointer is a non-zero, right? Now if my element at the current second uh, pointer is actually a non-zero, then in that case I will just swap these two elements, that is my first pointer element with my second pointer element, right? I will just swap them so that my 0 which I found at my first pointer is actually pushed forward, and this non-zero element that I got at my second pointer is moved before the 0, right? So that is going to be the first sub case if my element at the first pointer is 0. But now, for example, if my element at the first pointer is 0, of course, but my element at the second pointer is also 0, right? So in that case, what I will do now is I will just keep incrementing only my second pointer while my first pointer is still pointing to this particular 0 that I found. But I will just keep incrementing my second pointer till the point I hit a non-zero element, right? And whenever I see the first non-zero element, I will just then do this particular swap, right? With the element at the first pointer and the element at the second pointer. I will just do that swap so that again achieving the same thing, that my non-zero element would now come before my 0, and the 0 would be coming over here. It would be pushed forward, right? So that's what I'm going to do at every point, and I will keep doing this till my second pointer actually crosses the length of this particular array. That is, it crosses the last index of this particular array. I will keep doing this. And once I'm done, once my second pointer actually crosses the length of this particular array, I would be getting, this particular output where I have already pushed all the zeros in this particular array towards the right end, and all the non-zero elements would be towards the left end, like in the beginning. And I would be also maintaining the order of the non-zero elements, because if you see over here, what we are doing is we are doing the swap in that manner, right? So we are just trying to find the first non-zero element after the given zero, and we are trying to swap with that particular first non-zero element, right? So since we are every time just swapping with the first non-zero element, the current zero, we will be able to maintain this particular order of the non-zero elements, right? So this is the entire approach that we are going to follow to solve this particular question. I hope you understood it. If not, maybe you can just proceed further and check the solution that we are going to code now, and that will make things more clear for you, right? So now let's just jump to the IDE and write the solution together. All right, so now let's implement the solution. So what we can do is, first of all, let me just declare a function, and I can maybe call it as push zeros to end, right? Like this. And this will accept an integer array, right? And first of all, what I can do is I can take the length of the array, right? And then I can just initialize my f pointer to 0 and my s pointer to 1, right? That's what I can do. Now what I can do is I can run a while loop. And now what I will do is I will check those cases that we just discussed in the introduction video. So first of all, I will check if my uh, the element at my current first index is actually equal to 0, right? If it is not non-zero, if it is equal to 0, then I have to check if my element at the current second pointer is greater than 0 or not, right? If it is greater than 0, that means if it is non-zero, then I will just swap the first element with my second element, like this, right? With my first element, right? So this is what I'm going to do. And after this swap, I will just move both my pointers, the first and the second pointer, to the next elements each, right? This is what I will do in case my first element at the first pointer is 0 and my element at the second pointer is non-zero. But if my element at the second pointer is also equal to 0, right? In that case, what I will do is I will just keep incrementing my second pointer, right? And I will keep incrementing this. I will keep hitting this else condition till my element at the second pointer is actually equal to 0, right? The moment I find the first non-zero element at the second pointer, I will come in this particular condition and I will do that swap, right? Which I'm doing over here. So that's what I'm doing over here. And if my the element at the first pointer is non-zero, that is the else condition, I can just move both my pointers as is to the next element, right? I don't have to do any swap like this, right? And this is going to be the solution entirely, right? I can just keep swapping whenever I find a 0 with the first non-zero element ahead of that particular 0. And once I am exhausted, like I have exhausted all the elements of the given input array, I can just come out of this while loop, and by that point in time, I would have already rearranged this entire array to the desired output, right? So this is the solution entirely. I hope you understood it. Now maybe we can quickly test it so that we can be sure, right? So I will just use the simple test case that we also used in the introduction video. So it was, I think, let me copy it in fact to save time. And now it will be, let me print the array, the original array first of all, to compare it with the array later on, because we are going to do all this change in place. So now maybe I can just call this particular function that we wrote on this array first, do the rearrangement, and then again, you know, print this particular new reordered array, right? Now if I run this, let's see what we get. Yeah, so if you see, first I'm printing the original array, which is 120435050, And after we have done the rearrangement, we have all the zeros pushed towards the right end, and all the non-zero elements are in the beginning with their original order maintained, right? So this is the solution entirely for this particular question. I hope you understood, and I will see you in the next video. Thank you.